Thank you for attending this presentation today. I'm going to take you to a journey of three-dimensional electronics. We'll start very high, but we will see at the end of the presentation that it is possible. If you have questions, I will be happy to answer at the end of the presentation. And I will start with a kind of statement that imagine that you have a PCB with no vias, with the hassle of vias, that you have a perfect registration between the layers, but this is still thinking in layer modes, in 2D layers mode. And the next stage of it is try to think that drawing electronics in a 3D dimension, in a 3D space, and actually I kept the word PCB, but is because people need an anchor to have connected to what we're doing today, but eventually it will be a complete device. So in order to do it, we have to start to think 3D and not to think on layer by layer in how we design our current electronics. So in order to see it, I'll start with first what is AME, Additive Manufacturing Technology. I'll start with nano dimension implementation of it. And I will show you the roadmap for 3D structures that can be done with AME technology. And the second part of the presentation will be what tools do I have in order to do the 3D? If I have a good printer that can do 3D electronics, not 3D manufacturing, 3D electronics, I need to have a design capabilities which are not so available today. So just a very, very fast illustration. We have today technology, which is the PCB technology, many stages, wet stages. All people have already a lot of experience with it. And when we speak about AME, we're speaking about a very short process, actually from the design directly to the printing and then testing and shipping. Of course, today, we are not really within the PCB industry. We are aiming to go to the PCB industry. We are now in the research and development stages for research institute, even PCB companies that believe in these directions. They are buying systems in order to be ready for the 3D stage. But we have plans in order to bring complete systems to the PCB industry and to really change the way of doing PCBs. Okay, so this is not starting, so I will continue next slide. So actually, how we build the 3D elements, we have actually a printhead of isolation material and a printhead of conductive material, and the combination between the two elements, the two printers, we can build any structure of 3D interconnect device, which doesn't have to be all the time in the same structure of a two-dimensional structure. So I'll start with the anchor with the PCB, the normal PCB. And this is a cross-section of a PCB. On the left here, you can see a multi-layer PCB. In our systems, that we start from scratch. We build the isolator, we build the conductor, and we build we build it layer by layer. We can decide what will be the thickness of the conductor. We can decide what can be the thickness of the isolator, and we can do it in a very accurate way in order to maintain and to create a better strategy for impedance control. And we are not limited by layers. Today, if you have to do multi-layer, you think twice how many layers I'm going to do. This will increase me the price. Can we reduce? How we can do it? In this case, it doesn't matter. When we're speaking about plated through holes, we can imitate a PCB. We can do plated through holes. But this is, if it's not just for mechanical connection, we can convert it immediately to a via, actually a plated via. but actually it's not a via, it's a